So in this section, we're going to look at various forms of measurement and how to convert those measurements. But before getting into that, something we need to understand are unit fractions and also just how units kind of work together with each other. So as kind of a warm-up here, we're going to simplify these numerically and also look at what happens to the units as we do these different calculations. So with this first one here, 5 feet times 8 feet. So something we should notice here is that we have these two values, both of them have units to them, and we're multiplying them together. Now, numerically, we just treat this the same as we usually do. 5 times 8, which is 40. Fantastic. What we then need to understand is what's going to happen to the units. Do the units change? Like, we're still going to have feet, but is it different types of feet? Is it feet, feet squared, feet cubed, things like that? So with multiplication, what'll happen is you'll have the units feet, but they're multiplying together, and it's kind of like if we take a variable like x times x is equal to x squared. Same idea is that we're multiplying those units together, so they get squared right there. So something we want to notice is that when we multiply, so when we have multiplication, the units get an exponent. Oops. Units get an exponent. If we were multiplying three things together, like say then I multiplied this times 2 feet, then 40 times 2 is 80, and then feet squared times feet would make feet cubed. So the more you multiply a unit with itself, the more that larger exponent gets. Something you can notice here too, just to relate this to everyday life, is that this is a calculation for area. This is like if we had a rectangle that was 5 feet by 8 feet. This calculation is answering what the area is. So it's like we have 5, and then we have 8. So the area in there, there's 40 squares, so that would be 40 feet squared for the area. So just how you can see that it's turning into units that are squared, we have these square feet that are in there. Okay, so that's our first one. Key thing is if you multiply units, we get an exponent. Let's look at this one here. So we have 2 pi times 3.4 centimeters squared. This is similar to taking 2 pi times 3.4 centimeters times 3.4 centimeters. So that's all the square is doing, is it's telling us how many times to multiply it to itself. So numerically, we have this 2 pi, we have this 3.4, and this 3.4. Something we can notice is this 2 pi right here, there aren't any units there. So really in terms of units, we're just going to have this centimeters multiplying with centimeters, which will lead us to similar thing that happened just before. Just in case pi comes up, there's a pi button in the calculator here. So we could just go 2 pi times 3.4 times 3.4 to get a number out. I'm just going to round that to 72.63. I'm just going to go to 2 decimal places there. So 72.63. Now to figure out my units, I have centimeters times centimeters. So it's that same thing as that last one where this is multiplication. So with that, I take the units of centimeters, and since I'm multiplying them to themselves twice, it would be squared. And that would be our answer. So we want to work with the numbers and the units separately here. All right, this next one here, I'm just going to draw kind of a little line there. So we have 2 times 3.2 meters. So, and in fact, I'm just going to kind of do this for a moment. Let's just ignore what's going on over there, because with the addition, it's separating these terms that we can simplify first. So just doing this, 2 times 3.2 is equal to 6.4. So numerically, that's what we have. Now we have meters here. In fact, let me highlight the units there. And we have multiplication, but something to notice is that 2 right there has no units. So with this case, it's just doubling, like this 3.2 meters. Visually, what that is a distance. It's like you could have a string that's 3.2 meters long. And if we multiply that by 2, then we're getting a string that's 6.4 meters long. But it's still meters. It is not meters squared. So what happens here is this is just 6.4 meters. And it's not squared because that 2 right there is not meters as well. If there was an m there, then it would be m squared. But for this case, there's only 1 meters. Then, for this other one, and I'll just keep that addition symbol, same idea, 2 times 4.1 meters. So numerically, that will be 8.2. Again, we have meters there, but when it's multiplying, that 2 there does not have units to it. So it's just doubling. So it's like it's doubling the length of the string. So it's still 8.2 meters. So while there's multiplication there, it technically isn't multiplication of units. It's just multiplication with the numbers. And so with that, we keep the units as they are. Now what this turns into is addition with 2 things that have units to them. We have this 6.4 plus 8.2. So if we just add those together, that should be a 14.6. And then with our units, so we have meters and meters that are adding together here. Now, if you've seen this with algebra before, like say we had x plus x, what that would turn into is just 2x. So the 2 is coming from that we have one of these x's plus another one. So it's like we add those numbers together to get the 2. And then that just stays the same. It's like if I have 1 apple plus another apple, we end up with 2 apples. Same idea here. If I have 6.4 meters plus another 8.2 meters, then I have this total of 14.6 meters, not squared. So with this, with addition, units stay the same. So what this could represent, and actually going back to the original form of this is finding the perimeter of a rectangle. So if I drew a rectangle here, and we have 3.2 meters and 4.1 meters, and I wanted the perimeter of it, which perimeter is the length along the outside. So what I would have is 3.2 plus 4.1 plus 3.2 plus 4.1. So that's where we're getting double of the 3.2 and double of the 4.1. But overall, that distance along the outside would still be measured in meters. Again, it's like I can imagine a string having that length, and that string would have a total length of 14.6 meters. Whereas here, it turned into area, and with that, we had to change how we measure units into squares. All right, so with addition, the units stay the same. With our last one, multiplication and division, a bit here too. So if I simplify this down, so with fractions, we multiply our numerators together. So it's like I have 4 liters times 35 grams over 1 times 1 liter, which is really just 1 liter, because 1 times anything, you just keep it the same. Now, when you have a fraction like this, where there's all this multiplication and division, basically look to make sure there isn't any addition or subtraction. We can cancel things out, and that includes the units. So I can see I have liters in both the numerator and denominator. So those cancel out with each other. So with that, I'm going to have 4 times 35, which is 140, divided by 1, which doesn't really do anything. And the units I have left over are grams. All right, so that's just a little rundown of how units work in calculations. So with that, we'll come back to some of those pieces, especially this last one's going to be important for working with our unit conversions. So let's talk about unit fractions. So what unit fractions are, they are fractions equal to 1. So examples would be like 2 divided by 2, 150 divided by 150, pi divided by pi, really where you have the same thing in the numerator and denominator, those are unit fractions there. We can also revisit the idea of equivalent fractions, which we did in our fraction unit. We use these unit fractions to help us create equivalent fractions. So like if I had 2/3 and I wanted to create an equivalent fraction with a denominator of 6, I could multiply it by 2 in the denominator, but whatever I did in the denominator, I had to do in the numerator as well. That right there is a unit fraction. So we've used these before to help us make equivalent fractions. Now what we're doing here is we're adding units to it. So let's say I had 365 days. Well, if I divide that by 365 days, this is also just equal to 1. I have the same thing in the numerator and denominator. What we're going to do in this section, though, is that we can actually change it up a little bit so that it's still a unit fraction. It's just going to look a little different. So say instead of working with days, I wanted to work with years. Well, 365 days is exactly the same as 1 year. So if I wrote this as 1 year over 365 days, this is still a unit fraction. This fraction right here is exactly equal to 1. And what we're going to do is use this kind of formatting with these equivalent units to help us create these equivalent fractions. So we're going to see come through this multiplication of a number that's a unit fraction. So it's really just equal to 1, because when you multiply by 1, it's not technically changing the number, it's just changing how it looks. It's just part of this process will be changing the units. So let me give one more example here, and then we'll look at this conversion at the bottom. So let's say I was looking at 12 inches divided by 12 inches. Another way that I could write this is as 1 foot divided by 12 inches, because those two measurements are exactly the same. And if you're unfamiliar with these measurements or you're unsure of them, on this page I attached some common conversions and we're going to be using these. You can also find in our module underneath the outline and within the module, I attached 2 sheets for conversions. I'm going to kind of switch between the 2 of them. These would be good to have printed out or at least easily available to help you with these conversions and making these unit fractions. So this is one of them, and then the other one that we'll be using is this one right here. Some has more than the other, and then this one, I particularly like this one for when we get to working with the metric system. So be sure to have those around. So with this, we create a unit fraction. Notice that I could have done this as 12 inches in the numerator and 1 foot in the denominator, and that's exactly the same. All of these are equivalent to 1. This is 1, 1, 1, where the numerator and denominator are the same measurement. But what we're going to need to do is think about the different ways that we can order it, because that'll help us with our conversions. So let's see how this comes about. So if we have a string that is 18 inches long, I'm going to go ahead and make a visual for this. So we have a string that's 18 inches long. How many feet long is it? So what I could imagine is if I had a ruler, if I laid the ruler down, I could lay it down and that's going to take up 12 inches. If I lay it down again though, it only makes 6 inches to get to the 18. So I need to take out half of that foot if I have 2 of these rulers laying down. So really what this is 1 foot and a half foot. So in total, that distance would be 1.5 feet. And I'd be done there. However, I chose 18 very specifically because it's kind of nice visually for looking at this. What if I had made it 17 inches? Then it starts to get messy, and this is where we want to use these unit fractions to help us with the conversions. So we're going to have a lot of practice with these, but just to give you a setup for how we're going to go about these, is we want to think of a starting point, and we're starting with 18 inches, and what we're converting to is feet. So if I think about my start, I'm going to have a starting fraction. And my starting is going to use that 18 inches. So how I'm going to organize it is 18 inches. And then just to help with this fraction multiplication, I'm going to put it over 1. That's just going to help me line up my units in terms of numerator, denominator. So then what I want to do is similar to what we did up here with the equivalent fraction. I want to multiply by this version of 1 to help me get to where I want to go. So what I'm going to do is multiply by unit fraction. Now, we're starting with inches, and we want to convert to feet. So what I want to do is essentially cancel out inches. I don't want to see inches anymore. And with that, I would need to have inches in the denominator to have that cancellation. Just like we saw in this fourth example up above here, we need it in both the numerator and denominator to cancel it out. And what we want to replace it with is feet. So if I have inches here, then what I want to do is put feet up here in the numerator so that that'll be my remaining units. So my equivalence, which we actually looked at already up here, is that 1 foot is exactly equal to 12 inches. So what I do is 1 foot, 12 inches. So to create this unit fraction, we're thinking about how units can cancel out. We're also using these equivalents that we have from our conversion sheet. So the fact that 12 inches is exactly equal to 1 foot. So if we calculate here, like I was saying, the inches will cancel out with each other. So then numerically, all I'm left with is 18 times 1 over 1 times 12, which with that, we can use a calculator to help us out. What'll be helpful is you can separate up your fraction. So you have 18, and then the times 1 doesn't really matter, but if you like to type it in, you're more than welcome to. And then we have a 1 times 12. And there's our 1.5 that we figured out visually, but this is showing algebraically, or rather numerically, how we can get there. So from the calculator, we get the 1.5. And then for the units, the inches canceled out. So all we have left over is feet. And that would be our conversion. So we start with a fraction, and then we use a unit fraction to create a conversion so that we end up with the units that we want. Now, just real quick, what if I had messed up my unit fraction there? Just as a what if, I had mixed it up and actually put 12 inches in the numerator and 1 foot in the denominator. So 18 times 12 is going to make a big number. And then notice what will happen with the units. We'll have inches times inches, which will be inches squared, over, and then we'll have feet, so nothing's canceling out, and we would end up with a whole mess. So notice that while these are the same fraction, like they're both equal to 1, the order of the units matter, so we need to think about organizing it so that units cancel out. So we do not want to do what we did down there, but if you organize it incorrectly, it'll have this kind of backup for you of when you go to look at the units, you'll see that they're not in the right order, and that usually means you need to flip the fractions. So this is where we're headed with this unit. We're going to think about this calculation right here and setting up these unit fractions to create these unit conversions for us.